All right, 7.4, part number 2. So just got some more problems that I want to do here. So on this one, I've got u, the vector u, is say negative 2, 5. And our vector v is 4, 3. And then we're going to go through and compute a few of these. So 59, this just says find u plus v. Okay, so u plus v, there's a couple different ways to write this out. One would just be to say, well, u is our vector negative 2, 5, and I'm adding that to my vector 4, 3. So when you add these vectors, you do so component-wise. So negative 2 plus 4, comma, 5 plus 3. So when I add these two vectors, I'm going to get 2, comma, 8. That's it. Okay, 61 says find negative 4, say u. So that's negative 4 times this vector u, which is negative 2, comma 5. So when I'm multiplying by this number out in front, that's a scalar. I would just multiply each component by that negative 4. So negative 4 times negative 2 is positive 8, and negative 20. That's it. Okay, what about 63? So we get 3u minus 6v. So same thing there. If you want to write this out, 3 times u minus 6 times v. So this is really our vector negative 6, 15. And then here I'm multiplying this by negative 6. So negative 6 times negative 4 would be like a negative 24, and then a negative 18. So really I'm just kind of subtracting that or just adding that vector now. So negative 6 plus negative 24, that's negative 30. 15 and negative 18, that's negative 3. Okay, another way you could think about it is just to say that you're taking the negative 6 and then subtracting 24. That gives you negative 30. You're taking 15 and subtracting 18. That gives you negative 3. And that would be our answer here. Okay. All right, so I need to talk about special vectors here. There are two. There's a vector I, or unit vectors. So this vector I, that is 1, comma 0. So if you see an I in a vector context, know that that is 1, comma 0. And like I said, normally this is boldface, so do not confuse it with the imaginary I, because that I was actually kind of confusing. But this is, in this context of vectors that we're talking about, this is 1, 0. And J is 0, comma 1. And they're both unit vectors, which means that they are 1 unit away from the origin. Okay. So what we can do is we can write vectors right in the form AI plus BJ. And I can do that for my vector negative 5, 8 here. Okay. So all we really do is I take note of this, and I'll kind of write down what it is, and then you can see that that is actually the same thing here. So I have -5 in the x direction, so it's -5i, and I have 8 in the j direction, the y direction, so plus 8j. That would be how I would write it in that form. Why is that correct? Well, this is really -5. I is the vector 1, 0, and j is the vector 0, 1. So what I'm breaking this up into really its x and y components here, because this is really -5, 0 plus 0, 8, right? And if I add those two, -5 and 0 is -5, 0 and 8 is 8. So I can break up any position vector into this form. So like our -5, 8 would be -5i plus 8j in terms of our unit vectors here. All right, let's do one more just so you can. What about if I had, say, 2, 0? Well, in this case, this one would really just be 2i plus 0j. In this case, I wouldn't really need the j vector at all. This is really just 0. So the better way to write that is just to write 2i. To write it in that form. Okay, well, I want to talk about dot product. Okay, so how do I find dot product? So there's a computation, and then there's a further additional formula. And let me show you how I would compute it. So for vectors AB and V equal to CD, our vector U dot V, and this little dot is a dot product symbol. Okay. So as far as multiplying vectors, there's kind of different ways to do that, and it seems kind of weird. One of them is called the dot product, and you'll talk about another one later on called the cross product. But if I'm just doing a dot product to two vectors, what I would do is multiply these components. So I do like AC plus, and then multiply these components, BD. And that's kind of one formula for our dot product. There's another formula that I'm going to go ahead and give you right now for that same dot product, and that is U dot V is the magnitude of U times the magnitude of V times the cosine of theta. Now, what is theta? Well, if I draw a picture of my two vectors, say U and V, theta is going to be some angle between them. Theta is an angle between the vectors between 0 degrees and 180 degrees. So I want to first talk about how to use this formula, and then we'll talk a little bit about, well, how could I find the angle between vectors, and what does that mean a little bit more. Okay. So find the dot product. And we just have 6, -1. And we have 2, 5. Okay, so all I do to find the dot product is I do this vector, 6, -1, dot with this one, 2, 5. And to find that, I just do 6 times 2, and then plus -1 times 5. So this is really 12, and then minus 5, that's really just 7. So you're going to get some number. So I take two vectors, I do this dot product, and I end up with a scalar. So it's a way to combine vectors to get a scalar. So it's kind of an interesting. And then the number tells us something about the relationship between the vectors. Let's look at another one. Okay, let's look at 73. So we got 2, -3, and 6, 5. So same question there. Find the dot product. So I just do 2, -3, and then I dot that with 6, 5. So what am I going to get? Well, this is going to be 2 times 6, and then plus -3 times 5. So it should be -3. Okay, typically if the number is positive, that means that we have an acute angle, say, between the vectors. If the number is negative, that means we have an obtuse angle between the vectors. And then there's a special case where the dot product is 0. So I say that if the dot product, two vectors, is 0, then the vectors are orthogonal. Orthogonal looks like a fancy word. It just means perpendicular. Think about that prefix ortho. That just means perpendicular, basically. Like if you go to the orthodontist, they're in some way trying to straighten your teeth. Okay. Or like an orthodox religion. It's supposed to be, you know. Okay. So I want to do a couple with that. So determine whether the vectors are orthogonal. Okay. So I have 1, 2, and 6, -3. So they just give you that question. They give you the two vectors. They ask where they're orthogonal. All I would do to see that is I would do the dot product, and I would see if that is 0 or not. If that dot product is 0, that means they're orthogonal. Any other number, and they're not orthogonal. So I just do this dot product. So I got 1 times 6 plus 2 times -3. 6 minus 6, we're in good shape here, right? 0. I don't want that to be my answer. My answer is that they're orthogonal then. And that would be my answer. Since I got a dot product of 0. Okay, let's see another one. Say 88. Let's say 3, 4, and 6, 1. So I would do 3, 4 dot with 6, 1. 3 times 6 plus 4 times 1. I'm going to get 22. So they're definitely not orthogonal. I didn't get 0. Okay. Now, let's look at finding the angle between vectors. We'll do a couple where we do that. So find the angle between 1, 2, and negative 6, 3. Okay, so I'll show you how to do this. Basically, I want to use that formula, the second formula that we had, that's also valid for finding a dot product. And that formula was that, say, the dot product of two vectors u dot v was magnitude of u times magnitude of v times the cosine of theta. And if you want, you can call this a vector u, and I could call this vector v. So how do I go through and use this formula to find this angle now? And when I use this formula, our angles between 0 degrees and 180 degrees. Okay, well, I would first have to find, say, the magnitude. So magnitude of u here was 1 squared plus 2 squared, square root of that, so that's the square root of 5. And our magnitude of v was square root of negative 6 squared plus 3 squared. That would be square root of 45. So, and then I do the dot product. So u dot v, do that off to the side here. U dot v would be negative 6, 1 times negative 6 plus 2 times 3. That's actually 0. So I end up with this 0 is equal to u is root 5 times root 45. And cosine of theta. And I divide by root 5 and root 45 to get cosine of theta by itself. 0 divided by those two is just 0. And then what happens if I do the cosine inverse of 0? So what is that? The angle between 0 degrees and 180 degrees, where I get an output of 0, right? So you can see that's going to be 90 degrees. Well, the easy way to do this one would have been to note they're orthogonal. If they're orthogonal, that means that the angle between them is 90 degrees. So I'm just going to make kind of a sketch of our situation here. So dot product is 0. That really implies by this formula even that I got a 90 degree angle. So if I go 1, 2, here's u, and v somewhere over here at negative 6, 3. And what we're saying is that angle between those two vectors is 90 degrees. And that also bears out in this calculation. Okay. Let's look at, say, 78. One more like this. So this one I have 1, 7 and 1, 1. And we're trying to do the same thing, find the angle between the vectors. So I'll call this one u, and I'll call this one, say, v. So u dot v this time is 1 times 1 plus 7 times 1, that is 8. The magnitude of u is the square root of 1 squared plus 7 squared. That's square root of 50. And our magnitude of v is square root of 1 squared plus 1 squared. That is the square root of 2. So that when I use this formula, u dot v is magnitude of u, magnitude of v cosine theta. U dot v was 8. This was square root of 50, square root of 2, cosine of theta. So really I just get 8 divided by, this is really just the square root of 100. Actually, I can simplify that. Square root of 100 is really just 10. So this is 8 equals 10 times the cosine of theta, and I divide, 8 divided by 10 is 4/5. So I end up with this 4/5 equals cosine of theta. So all you have to do at that point is take the cosine inverse. If you're in degree mode on the calculator, that will get you what you want. Okay, so degree mode, since we're after the angle in degrees between those two vectors, and cosine inverse of 4/5, and we are going to round to the nearest hundredth of a degree, so 36.87 degrees. Okay, that's what you would do on those. That's really only computation that you would have there. Okay, so do I want to do? I think that will be 7/4. That's kind of what I wanted to get through before I make this video even longer than that. So it'll be kind of one assignment on 7/4, and that will be kind of Tuesday's assignment. Okay.